All the way.
All the way, yeah. Thank you. All right, so chapter 3, major substances abuse in the body. So we're going to talk about the brain and mainly how substance use, not just in the state of intoxication, but like long-term chronic use and how it can impact the brain. So today we're going to start off talking about the corpus callosum. Can you switch forward real quick and then back? Okay, so this is the corpus callosum, that green area. So the corpus callosum is in the middle of the brain. And if you think about the brain, it's split into two pieces, into two hemispheres, right? So you got the left brain and you got the right brain. The corpus callosum acts as a bridge in between the two hemispheres of the brain so that they can kind of communicate with each other, right? So you can go back to the first slide. So different hemispheres of the brain do different things. The left hemisphere controls the right side of the body. So left, it's like the opposite of your body. The left controls the right side of the body, and it has more of the actual cognitive, like the thinking part, the logic, verbal ability, producing and understanding language, and the use of words. Whereas the right hemisphere is more, if you think of it as like how you view things, almost like the artistic side. So it's involved with, it says temporal and spatial relationships, analysis of nonverbal information, and communicating emotion. So it's like the part of your brain that activates, say when you're listening to music and a feeling comes up for you, you know, that's coming from the right side of your brain. If you're looking at a picture, you're looking at the view on the parking lot and it's, you know, connecting you to memories you may have, or you're like, oh, that's beautiful. So that's the part of your brain that's analyzing what you're seeing, is the right side, the right hemisphere of your brain. Okay, next slide. And then thank you. So the hindbrain, so if you think of the brain as split up into three parts, there is the hindbrain, the midbrain, and the forebrain. And so the forebrain is in charge of all the things that's like voluntary. So these are the things that you are thinking about doing, that you're making decisions to do. Whereas the midbrain and the hindbrain are involved with involuntary things, right? And so what I mean by involuntary things is you don't have to think about breathing, right? You just breathe. Matter of fact, if you purposefully think about stopping yourself from breathing, right? Try to hold your breath, you're not going to be able to keep holding your breath past the point where your body starts to get harmed, right? Your body forces you to intake air. So that's that part of your brain that's housed in the midbrain and the hindbrain that houses that involuntary things. When you eat food, Jesus Christ, when you eat food, for example, and the food travels down your esophagus into your intestines, you don't have to think about making your food travel down into your intestine. You don't have to think about making your food get digested, right? So that's the automatic part of your brain that's moving things along, that's telling your digestive system to do its job. It's telling your lungs to inhale and exhale. It's telling your kidneys and your liver to filter out anything that's in your blood or your body that you don't need, and it makes urine. So the midbrain and the hindbrain are going to be in charge of those involuntary aspects of your brain. Bless you. So the forebrain, like I said, goes back to the things that have to do with logic, the things where you're consciously making an effort, you're making a decision, you're thinking about things, you're thinking about the consequences of those things, and you're making the decision to do those things. Those parts of the part of your brain that's in charge of that, it's all going to be housed in the forebrain. Next slide.
The part of your brain that's in charge of what you said.
The forebrain. The forebrain is in charge of the part of your brain that has to do with reasoning, making decisions, logic. Whereas the hindbrain and the midbrain, both of those parts of your brain are more for involuntary things. So like blinking, you don't have to think about blinking, you just blink, right? If you try to hold your eye, if you try to keep your eyes open like this, I can't even hold my eyes open, I already blink. You blink, right? Right. So Tanya and Lynette. So just to catch you up where we're not too far, we just talked about how the brain um, is there's the left hemisphere, the right hemisphere, and in the middle of those two hemispheres is something called the corpus callosum, which acts like a bridge to make sure that both sides of our brain is communicating with each other. Because the left side of the brain and the right side of the brain have two different jobs. One side is going to be dealing with logic and reasoning, making decisions, analyzing things, whereas the other side of the brain is going to be in charge of more almost like artistic things, like listening to music and the feelings that come from that, looking at the view and admiring how beautiful it is, making art, so spatial relations, like um, so the corpus callosum communicates both sides of the brain. The brain is broken up into three sections: the midbrain, forebrain, and the hindbrain. And so, as I said, the forebrain is the one that's in charge of voluntary actions like thinking, making decisions. The hindbrain helps to regulate automatic functions, coordinate movement, maintain balance and equilibrium. So when you learned how to walk, right now we just walk. There's no real thought in it. We just get up and walk, right? So the hindbrain is going to be in charge of making sure we're not falling over, that we can see the different divots in the road, like when we're walking, and we'll be able to navigate it without falling on our face. That's the hindbrain automatically providing that equilibrium for you. The midbrain is in charge of auditory and visual information. So right now, as you're listening to me, the midbrain is what's taking the information and taking it to the forebrain, and it's analyzing what I'm saying, right? It's in charge of taking the information so that it could be deciphered, right? Okay. Can you go to the next slide, please? Thank you. So inside the brain, there's the limbic system, the diencephalon, and neurotransmitters. So to break it down, basically, when you're using substances, whether you're using it for the first time or if you're using it chronically, meaning repeatedly over a period of time, it's going to impact your brain. It doesn't matter if it's your first time. And how it impacts the brain is there's things inside of your brain called neurotransmitters. Skip forward one slide, please. So as you can see, this is how people communicate, right? There's a transmitter, that's the signal is going out. And there's a receptor, the one person that's listening, that's the receiving the messages, right? And so the brain and the neurotransmitter works the same way. There's the neuron that sends messages, and there's the neurotransmitter that sends out a message, and the receptor is what picks it up. Different neurotransmitters are like different, we'll call them different flavors, you know what I mean? So you can have a neurotransmitter called dopamine. Dopamine is that's the gummy bear of the that's happy, that's we going to town, we going, woo, okay, that's the dopamine, that's the neurotransmitter. There's other neurotransmitters like serotonin. Serotonin is in charge of regulating your mood, so you're not like woo 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 all the time. And so there's many different kinds of neurotransmitters, and it sends the messages. When you're using substances, the messages get blurred. Either there's too much of a neurotransmitter. So for example, when you're using methamphetamines, it floods the brain with dopamine. It means it's way too much. It's way too much dopamine. So that gives that feeling of elation. You're going fast. It makes your heart race. You can't stop talking. You can't stop moving. You're not thinking about consequences. You're just doing stuff, right? Same thing with cocaine. It's going to be a flood of dopamine. So, you get that rush, that elation, that happiness, that feeling of invincibility, right? And so what will happen to the brain over chronic use is that receptor, that part of the brain that is receiving the information, that can get burnt out, right? And over time, if things get burnt out, what ends up happening is the chemical changes, right? If you're familiar with someone who was using stimulants, that's meth or cocaine, when they stop using drugs, they get irritable, they're tired, They want to eat all the time. They're sleeping all the time, right? And that's a sign of the body and the brain trying to adjust to make up for the fact that those high levels of dopamine isn't there anymore. Because no matter what, even if you're on drugs and it's changing the chemicals of your brain has to adjust, right? It has to adjust so it can function. So that state of functioning, that's called homeostasis. Homeostasis is basically like, this is the peak of the functioning of your body and your brain. Like when you can, you know, be able to take in information, communicate information. And when you're using drugs and the chemicals get more, either there's more neurotransmitters or there's less of, your body has to, and your brain has to adjust to it. That process is called allostasis. And so after a period of time, if you're using drugs, right, and then you have to use more and use more and use more to achieve the same effect, that's called tolerance, your brain will then have to adjust until it can function again. I know that was like a whole lot of stuff that I just threw at you, but that's basically that communication between the neurotransmitter, the receptor, and drug use. When we go into pharmacology, you'll get a better understanding of what I'm talking about specifically. But I didn't want to like just go into it and not have that explanation because that's going to be confusing, right? Okay, next slide. Does anybody have any questions? I don't want to keep going if any part of that was unclear or confusing.
I can read all that in the book.
I'm going to be posting this into the module.
Okay.
Yeah. Okay. But all this information is in the book. So if you have the book, if you look on page 53, this is where this information that I'm talking about starts.
Okay.
So as I said, drugs interfere with the way neurons send and receive and process signals via neurotransmitters. Some drugs like marijuana or heroin, so those are depressants, can activate neurons because their chemical structure mimics that of a natural neurotransmitter in the body. So, for example, in the brain,
This one might be.
So in the brain, so think of this as like the neuron, right? Mm-hmm. So there's natural neurotransmitters and receptors for opioids. Does everybody know what an opioid is? So an opioid is a type of drug, a class of drug. It's a depressant that's going to be made from the poppy plant or synthetically made. So that's heroin, that's methadone, that's fentanyl, that's oxycodone, things of that nature, right? Mm-hmm. And so the reason they were created, aside from heroin, methadone and thing, it was for pain management, right? Mm-hmm. So the opioid receptor, in the brain, its job is to deal with pain management. So when you go to the doctor, you have surgery or whatever, and they give you morphine for the pain. So there's a neurotransmitter that gets released once the morphine enters the brain, sends a signal for the neurotransmitter to be released, and it sits here, right? Think of this as the neurotransmitter, this little box, and see how it fits perfectly inside this little case, the receptor, right? And so what it's doing is it's blocking out pain. It's creating that feeling of relief, the elation that people can feel when they're on opioids, right? And sometimes other normal occasions, like after a woman gives birth and she has her baby, there's hormones and things called oxytocin, right? And so those hormones also do something similar where it helps to kind of dull the pain. It kind of puts them into shock, and it also helps them to bond with their baby. It's the same situation where a neurotransmitter is released naturally by the brain, and it sits in this thing here, Now, what happens is you do the drug heroin, right? And oftentimes the drugs that we use, drugs of abuse, have a higher, when they say higher action potential, that means that they are more powerful in the messages that it's sending. So it'll kick out the natural neurotransmitter, right? And so that's gone. And instead, the neurotransmitters that are released by, is there another color?
So this one's open, so I know this one.
That's okay. So now there's a new receptor in here, and that's from the drug. That's from, we'll say, heroin. So because heroin fits so easily in the receptor, the opioid receptor, the natural, this was the natural neurotransmitter. So it kicks it out and it stays like that. That's why when people are first getting off of opiates, why it's so difficult for them, because it's literally replaced the natural neurotransmitters, the natural chemicals that's in the brain. It's replaced it, right? That process of homeostasis that I talked about and allostasis, that change that happens in the brain where it's trying to adjust to all the different changes. If there's supposed to be, you know, only this many, right? Ooh. Oh. Say the brain functions with these many neurotransmitters, right? This is its peak performance. Like this is when it works the best. This is the natural stuff. And then they do heroin chronically, and it starts to kick out all of the regular natural neurotransmitters, and it floods the brain with all of these neurotransmitters. So then the receptor gets burnt out, right? It can't take that much. Can't take all that. So then it's flooded. And then the brain has to figure out again how to function with that level of neurotransmitters, with that level of dopamine, with that level of serotonin, or whatever the case may be. And then when you suddenly stop using, right? The brain doesn't know the difference between when you have a drug problem and when you don't. It doesn't know the difference between drugs that you're supposed to have or neurotransmitters that you're supposed to have and things that you're not supposed to have. All it knows, it has to adjust to function. So if it's used to this flooded stuff and all of it's gone now, it has to go through that process again of adjusting so that it'll function. And that's where like the withdrawal and detox come in, because the brain literally is going through a change. It went through a change in the beginning when they started chronically using, went through a change again when they stopped using. So that's why when people say, oh, why can't you just stop? It's not that simple, because in reality, the brain, which is an organ, has been changed, right? And so just like you wouldn't tell a person with kidney cancer, you wouldn't just say, just stop it. You just stop that shit. Fix it. Like, it's not going to be able to do that, right? So why is the brain, which is also the brain that's not even here, that I just erased. I'm not a good drawer, but we'll say this is the brain. No, let's not do that. We gonna confuse y'all. You'll be like, what is this piece of broccoli on the? But yeah, the brain is an organ, just like the kidney is an organ. It's very clear to us when we say, if I tell you cocaine impacts the heart, it's very easy to understand. Oh yeah, I can see that it makes the heart go fast. So it's going to make the heart muscles work harder. So then the heart muscle is going to deteriorate. right? Because it's having to work so hard. So it's the same principle with the brain, but the difference is we don't see it as easily, right? We have a lot of messages, cultural messages over time that tell us that a person who's on drugs is weak. They have a weak moral compass. They just want to have fun. They don't care about responsibilities. We don't actually see that the brain chemistry is actually changed. And even after a person has achieved sobriety or abstinence, even if they've been abstinent for 5, 10, 20 years, the pathways that were formed in the brain don't go away. The brain remembers, like, oh, she remember. I don't know what's that thing that made it was really fun though. I really like that. So if they seen it again, he'd be like, oh hey, it's that again. So let's get some more, right? Next slide. Yes. Mm-hmm.
That's alcohol.
Yeah, that's alcohol, right?
So with alcohol is one of between alcohol, benzos, opiates. Alcohol is the most dangerous of them all. Alcohol is the only one that you can die from a detox. With heroin and opiates, you may feel like you're gonna die. You may feel like you want to die, but you're not actually dying. Whereas with alcohol, you are dying. And so basically the reason why a person gets wet brain is there's certain neurotransmitters. So the same thing that we were talking about. Can you go back one slide? So there's certain neurotransmitters. It gets burnt out. It's called GABA. I'll post something on the module that kind of explains it some more. But GABA, acetylene, there's different chemicals in the brain that's impacted by alcohol use. And so repeated alcohol use, not only does it change the chemical of the brain, but it also changes its structure, right? So, those folds that are all throughout the brain, those begin to break down. And so the difference between someone who may be on meth or heroin, the changes that come from the use over time can repair, not fully, right? But it can repair. But when it comes to alcohol, it doesn't repair. So it's not just the chemicals inside, it's the physical structure of the brain. Does that make sense? Okay. Does anybody have any other questions? Okay. Go back, next slide, thanks. This one. Okay, thank you. So as I was saying, the way that drugs impact the brain, it changes the chemistry, changes the neurotransmitters, or the things that carry the messages from one part of the brain to the next. And so another area that it will impact, it talks about the hypothalamus, the median forebrain bundle. Can you go to the next one? So inside the brain is the reward center, right? And so the reward center is a very old part of the brain. It's part of the brain that's not voluntary, right? So earlier I talked about the forebrain being in charge of like logic, making decisions and choices. So when it comes to the reward center, it's automatic. This is not the part that you can think of, right? And so long ago in the caveman days, there's 3 essential functions we need, right? We need to eat, we need to sleep, and we need to procreate, meaning have sex and make babies to continue the species, right? And so anytime that we eat, anytime that we sleep, anytime that we procreate, the reward center activates. It releases things like dopamine, and you're gonna hear me say dopamine a lot. It releases things like dopamine and other neurotransmitters that make you feel good, right? And so the reason why it does this is because then it stimulates you to continue the same behavior, right? obviously if you don't eat, if you don't sleep, you're gonna die, right? So the brain naturally has these kind of like a fail safe in place so that you will continue to do these behaviors. Now, when you add drugs to the equation, it'll hijack that system. And here's why. So earlier I talked about the receptors, right? And how normally you have things in them and the neurotransmitter sends messages being happy, feeling satisfied, whatever the case may be. When you're playing with your children and you have that feeling of love and comfort, you know, that's coming from dopamine. That's the message that's being released by the brain. But when you do drugs, it floods it, right? It burns out these receptors and your brain gets used to this high level of drugs. So like, for example, meth will produce 100 to 500 times the amount of dopamine you would get from eating a good meal, from spending time with your friends, from hanging out with your children. It'll release 500 times that amount, right? So your brain is hardwired to repeat this behavior when it experiences that message, the dopamine, among other neurotransmitters. The message it gets is this feeling is associated with behaviors that keep us alive. So sometimes you'll hear clients talk about how they have to, like, they feel like they can't function without it, right? They feel like if they don't get high, they're not going to be able to do anything. And to a degree, that's true in their brain, literally. They feel like they can't, they're going to die without it. And it's because the chemistry of the brain has changed due to the neurotransmitters and like the imbalances that have occurred through ongoing use. Does that make sense?
Yes.
So again, when you take it away, the brain is so used to 500 times the amount or whatever the case may be, depending on the drug that they're using, that there's a period of depression, there's a period of anger, there's a period like where they do struggle to function. And depending on if it's alcohol, if it's benzos, if it's opiates, there's going to be a much more intense withdrawal period because the brain chemistry has changed. And so when people ask, again, why can't you just stop? I was like, what's the matter with you? Sometimes you'll get a client that is so wrapped up in shame. You may have a pregnant client who was unable to stop using while they were pregnant, right? And is genuinely asking you like, why can't I stop, right? We're not expecting you to be neuroscientist that's going to be like, well, this is the basal ganglia and this is the acumens, like, but having this general understanding of how the brain works with chemicals, you can sit there with your client and be like, look, when you were using drugs, it changed the way that the makeup of your brain. Your brain got so used to you putting this certain thing in your body that when you're without it, the brain thinks it needs it to function. And as I said, when it comes to dopamine release, like I said, if you are doing methamphetamines and it releases 500 times the amount of dopamine you would normally get, as opposed to when you hold your child, I'm telling you, so it literally produces more satisfaction or more happiness of at least the chemical that creates that feeling, literally releases more than you spending time with your child. Like, does it make it better? No, but it's a good thing to be able to explain to your clients, like, you're not this big piece of crap that just didn't care about their baby. Like, your brain is literally hardwired to repeat behaviors that stimulate the reward center, because the stuff that stimulates the reward center are things that are associated with life continuing behavior, eating, sleeping, having sex for the procreation of the species. So your brain is literally hardwired to repeat that. It's not any of your own choosing. You're not logically deciding, you know what, sounds good. I think I'm gonna go ahead and smoke some crack and go ahead and let the people come take my baby. I think that sounds like fun. Nobody says that. Nobody feels like that, you know? Um, and then that same question too, when it comes to relapse, right? It's the same situation. Now, after time, the brain will begin to repair itself to a certain degree. But that pathway, that brain knows that there's something out there that gives me this much more of this dopamine. Can you go to the next slide, please? Okay, so the brain reward pathway, that's what I've been talking about. There's a bunch of different parts, but the main parts that I want to talk about is the amygdala, the hippocampus, the hypothalamus, and the prefrontal cortex, right? So the amygdala, that's part of your brain, it establishes associations between whether something was really rewarding or aversive. So it will remember when you went down to the cut and you picked up that bag and you smoked that rock, it will remember that happy positive feeling that you got from going down there, right? It's going to remember that when I do this particular thing, I feel really good, right? I have this, the reward center is stimulated. So I'm going to remember this. So that's why you have clients, if they drive down past that same cut, you know, they go over there by E14 and they catch a feeling. They feel squirrely, their heart's beating, they're sweating, right? And you're like, what are you going through, ma'am? It's because the brain, the amygdala specifically, remembers because, you know, addicts, people who are addicted have patterns. They'll call the same person. They'll go to the same liquor store. They'll get the same, you know, pint. They'll get the same pipe. They'll get the same Brillo pad over here. They'll walk over to the same corner. They'll talk to the same person, and they'll keep doing it over and over again, right? And if Benny Blanco ain't got what I need, I'm gonna go over here to Smokey. And if Smokey ain't got what I need, I'm gonna go back to Benny. And if Benny ain't got it, I'm gonna go over here to Sally. And it's the same thing over and over and over again, right? And so it remembers those. So when you go through those same areas, you're gonna have that feeling. So some clients get triggered. It could be a song that they used to listen to over and over and over again when they were getting loaded, right? They hear the song and they remember. The amygdala triggers that memory. Oh, remember when you was smoking and you was listening to this song? Woo, I remember. And the next thing you know, but did you remember when you lost your ass though? So yeah, another piece of the reward pathway, it remembers that this was a good thing. I mean, not literally a good thing, but a good feeling. And then the hippocampus is the second part of that, right? This is the establishing that memory, right? So the amygdala determined this is a good thing. When I go down to E14 and I talk to Benny, right? And I get this bag, I feel good. The hippocampus remembers that. Okay, E14, that's the one, that's the spot. This is when I felt good. This is when I felt powerful. I felt strong, right? And then the hypothalamus is the other part of the brain that coordinates with the rest of it. Like, oh, remember, like the reward. This is the reward that we got. Remember how we felt when we came over here? We got to remember this. So all of these things together work together with the prefrontal cortex. So the prefrontal cortex is the part of your brain. It's not the only part of your brain, I'm sorry. It is part of your brain that's in the forebrain, that part that I was talking about that was in charge of voluntary things. That's the part where you actively think, you use your logic, you make these choices, right? So the problem is when you have the amygdala, the hippocampus, the hypothalamus, among other things, remembering the positive aspects of use, when your prefrontal cortex goes to make that decision, it weighs the options. Should I pick up again? Should I go down to that same street again? Should I call that person again? Oftentimes, you're going to get 50-50. You're going to get somebody who's not going to remember that, okay, yeah, all this stuff feels good, but I also go to jail. I also end up homeless. I also end up having to sell my body. I also have to, my kids are gone. Like you would think that those are things that they would remember, but the part of the reward pathway in your brain, it will remember things to a certain degree. Does that make sense? And then next slide, please. I don't know. Yes.
So when you say remember things to a certain degree, what about I remember the bad part and that's why I don't eat them?
So the bad part, that comes from once you've achieved some level of recovery or sobriety and you've been introduced to new activity. So they tell you, when you feel like picking up, call your sponsor, call your friend, go to a meeting. So you are making new pathways instead of going to E14 and getting that bag from Benny. Now I'm calling my sponsor Yolanda. I'm going to go to a meeting instead, right? And so your brain starts forming new patterns to deal with the same stimulation. And by stimulation, I mean a stressor. You get in a fight with your significant other, you lose your job, your mom is sick, your light's about to get cut off, right? And in the past, someone who didn't have any information, any coping tools before would just do the same thing because that's all they know, right? That's how they cope with it. And then someone who is introduced to, they might not get it the first time, right? It might take a couple times. It's not an indication of how dedicated they are to recovery. That's just an indication of how badly affected the brain is. It's not a on purpose thing like, I really like to embarrass myself and be homeless more than once. No, it's not like that. You know what I'm saying?
Right.
But for those pathways to get really to be really forged, for the brain to start following that, you have to do it over and over and over again. So that's why they tell you there's different types of recovery. Like it's not always meeting attendance. There's other forms of recovery, but I will use that as an example. That's why they tell people continuously continue to go to meetings, continue to work your steps, continue to call your sponsor, continue to be in service. They tell you those things over and over and over again because your brain will never forget that rush, that 500 times amount of dopamine that it can get from over there. And so when you're not being mindful, when you're not actively working a program, using coping skills, right? And that's why treatment and our involvement in treatment is so powerful, is because without that, they just literally only know, and their brain only knows this one thing, right? It's not because, yeah. And it's not because they said, what, I really like having no teeth. You know what, Anna, it's just, I love it. I love it. The way that it just breaks off, just like, oh, beautiful. I love it. I enjoy it so much. I really like not having clean underwear. It's a matter of fact, let's just turn it inside out. Let's just do that. I don't know. It's the best. It's something about it. The smell, makes me feel alive. Nobody says that, but the brain, that unconscious part, right? The midbrain and the hindbrain that's involved with the automatic stuff. It's automatically sending our clients on that mission, so to say, because it literally, like I said, it wants to do the things that activates its reward system because it believes the things that stimulate it are things that will keep it alive. Because naturally, before we were ever introduced to drugs, naturally, that's true. The only things that really activate these are things that keep the person alive or the species alive. So that's eating, sleeping, spending time with your offspring, spending time with your mate, etc., so on. But once they get introduced to substances, it's a whole different ballgame. So in this icon or picture that we have here, it's just basically illustration of what I'm saying. So the first blue box, it shows you the natural amount of dopamine that's getting released from eating food, right? So if you see a couple, it's nice, it's a lot. You see a couple receptors go, okay, all right. But then when you have cocaine, you see how many more orange balls there are, right? And so it's flooding it. It's flooding it to the point where the brain can't handle it. There's more dopamine than there is receptors. There's more for it to be able to absorb. The brain has to adjust. And so what it does is it stops making its natural chemicals. It stops making its natural dopamine so that it can handle what's already existing in the system. So when you remove it from the system, the client is going to experience withdrawal because the brain has been used to not releasing its own natural chemicals. Does that make sense? Okay. Does anybody have any questions so far? Okay. So let's go ahead and take a break. Let me stop this.